Okay, so today is Friday, September 26th. I'm going to show you how to use compute or technology to compute normal probabilities. And we're going to first start off with StatCrunch. So from within the MyStat lab, you are doing your homework and you come across a problem and then you need to compute a normal probability. So you can launch StatCrunch. How can you launch StatCrunch? Well, here's a homework problem, and off to the right you see the StatCrunch link, so you select on StatCrunch. Okay? Now, let's go ahead and click on Statistics, and then Calculators, and then you go down to Normal. Now, notice that there are two options here. You got standard and between. And you might even see a third little link up here that gives you 68, 95, 99.7% tick marks. But you don't need that. But it's handy to have the between. But we'll look at the standard right now. The standard is going to calculate the probability that your X random variable is less than some number, or even greater than some number. So the mean, you choose a mean. By default, it gives you 0 for the mean and 1 for the standard deviation. So in other words, a standard normal. But you can change that mean to anything. So if we're talking about body temperatures, you could choose a mean of, 98.2 and a standard deviation of whatever, 2.1. I'm just making up some numbers here. And if you want to calculate the probability that someone's temperature is less than 100.3, then you could just type in that value of X there. And then notice that this other window here will become blank and you hit compute. And then the StatCrunch calculator here will compute that probability. If you want to calculate the probability that X is greater than or equal to, then you can change this by clicking on this link here. You'll calculate the probability that X is greater than that number. You could also go backwards. You do a reverse lookup. If you want to calculate the value of X that's at some percentile, like, the 65th percentile, just put in 0.65 or whatever for the probability. And make sure that your inequality symbol points in the right direction and then hit compute. So, if you want to calculate the value of X that corresponds to, 0.73 area to the right, then you could do 0.73 and then that'll compute it with the appropriate shading. So you could do your inverse normal lookups there. So you could specify a value for X and then compute the probability, or vice versa. Now, this will calculate the probability that X is greater than a number or X is less than a number. Now, if you want to look up the probability that X is between two numbers, then you could check or click on this link right here, between. So if you want to calculate the probability that, X is, someone's body temperature is between, 0.7, and 100.2. And then there you go. Of course, make sure that you put the appropriate mean and standard deviation of your distribution there. Okay? So that's it for StatCrunch that I wanted to show you. I wanted to show you something on Excel. So you can launch an instance of Excel and then click in any cell on any worksheet. And then if you want to compute some normal probability distribution or some normal distribution probability, put equals norm dist, N-O-R-M, D-I-S-T, open parentheses, and then you can see the syntax right here that tells you what numbers to put in. Now this will calculate area under the curve to the left, just like we would look up in a table. So if you want to find the area under the curve to the left of, I don't know, thinking about temperatures again, 100.2 maybe, comma. And you can kind of see it's going to give you a hint as to what the next number that you need to put in. Okay, what's the mean of the distribution? Maybe 98.2, comma. Standard deviation, maybe 2.1. And then the last thing you need to tell it whether it's cumulative or not cumulative. Now, for continuous distributions, you need to put in true. Otherwise, if you do false, the probability is going to be 0. Because the probability that your random variable is equal to any particular value is 0. All right, and there's the probability. If you want to do a reverse lookup, do equals inverse norm. So equals inverse norm, sorry. Inverse norm. Or is it norm inverse? Yeah, norm inverse. Inverse norm. And then you could see the syntax for the numbers that you'll put in there. And so you'll put the area under the curve to the left. And so let's just suppose it's like 0.73 or something, comma, and then what's the mean? Well, let's suppose it's 98.2, and the standard deviation, well, put in the standard deviation, maybe 2.1, whatever, and there you go. And okay, so this tells you that, you know, if you want to find the temperature that's at the, 73rd percentile, and that temperature works out to be about 99.49 degrees.
Can you show that for me?
Yeah, so that's going to be equal to norm inverse. And the first number that you put in is area under the curve to the left. So this time I'll do 0.89. And then the mean, again, now let me just say, stop right here. What if you just leave it like that and you forget? It's going to tell you, what your mistake is. And, oh, you have to put this stuff in, huh? Okay, so I have to put in the mean and the standard deviation, separated by commas. And there you go. Now, if you want to find the area under the curve between two values, so what's the probability that someone's temperature is between, I don't know, 97.8 and 100.2? So put that lower value here, 97.8 or whatever that was, 98.2, 2.1, comma, oops. And so this will take the big area minus the small area. Okay. All right. So any questions about Excel? How to use it to calculate normal probabilities? And then, of course, the star of the show is the graphing calculator. And as you can see here, normal CDF is the command. So how do you get to it? So you remember the distribution menu? So go to second and then into your distribution menu. normal CDF. Do you remember what CDF stands for? It's something distribution function, right? But what is the C? Cumulative, yeah. Cumulative. Normal cumulative distribution. So go ahead and select that second option. And the syntax here is that you need to put in a left limit and a right limit. So if you want to find the probability that someone's temperature is between 97.9 degrees, well, put in 97.9, comma, and then 100.2 or whatever that right limit is. Now, if you leave it like this with the closed parentheses, what do you think is going to happen? Yeah, not very good, huh? Why do you think it came up 0? Because of the fact that if you only put those two numbers in, the left limit and the right limit, it's going to assume that the mean is 0 and the standard deviation is 1. It's going to assume that you're talking about the standard normal. So if you want to calculate normal probabilities for anything other than the standard normal, then you need to put in the left limit, comma, right limit, and then comma, the next or third number is going to be the mean of the distribution, call it 98.2. And what do you suppose the fourth number is going to be? What do you think? Standard deviation, exactly. Standard deviation of your distribution. Call it 2.1 maybe. And then hit enter. There it is. So that means that if you randomly select someone to get their temperature taken, there's a 38.6% chance that their temperature will be between 97.9 and 100.2 degrees, for example. Now, if you want to calculate the probability that x is less than some number, that's the same thing as calculating the probability that x is between negative infinity and that number. But how do you do infinities on your calculator? Well, I'll show you. That's a good question. I'm glad you asked, because I'm going to show you right now. So let's do normal CDF, and suppose that we want to calculate the probability that someone's temperature is less than 100.2 degrees. The left limit is going to be negative infinity. There is no negative infinity here, or positive infinity. No infinities here. But you can put in a rather large magnitude negative number, like negative 1,000 or negative 1,000,000. You could make it as small in the negative sense that you want. So if you want to do an extremely small number, you can do a negative 1,000 with as many zeros as you like. Most people find that negative 100 works just fine, close enough to negative infinity for the purposes of normal probabilities. Now, I'm in the habit, though, of choosing negative 1 times 10 to the 99th power using scientific notation. And you see this little EE? That means times 10 raised to the scientific notation. So negative 1 times 10 to the 99th power, that means negative 1 with 99 zeros to the right. Everybody understand what I'm saying? So, hey, whatever floats your boat. As long as this is just a rather large negative number, everybody understand what I mean? As in like a negative 1,000,000, negative 1,000,000,000. And then, comma, so that'll be the left limit. The right limit, of course, will be your other number, like 100.2 or something. And then the mean, call it 98.2, and then the standard deviation, call it 2.1, close parenthesis, hit enter. Okay, so this tells us that about 83% of people have temperatures less than 100.2 degrees. What do you suppose that we could use for right infinity or a positive infinity? Well, probably 1 times 10 to the 99th power, or 1,000, or some large positive number. So if you want to calculate the probability that someone's temperature is greater than, say, 97.8 or something, well, put in your left limit there. Right limit would be positive infinity, which I could write like that. That's 1 times 10 to the 99th power, comma. The mean, 98.2, and standard deviation, 2.1, and hit enter. Okay. Now, regarding doing a reverse lookup, we have inverse normal in the distribution menu, which is option 3. And if you tell it the area under the curve to the left, then it'll tell you the corresponding value of x. Now, let's just put in some number. That's between 0 and 1, of course. Some area under the curve to the left. So, like 0.37 or something. Now, if that's all you give it, it's going to assume that it's the standard normal that you're talking about. But if you are dealing with some other distribution besides a standard normal, if it's normal with some other mean or standard deviation other than 0 and 1, then you need to tell it the mean and standard deviation of your distribution. So if I want to find the value of the temperature that's at the 37th percentile, then I could specify the mean and the standard deviation like that. Okay, 97.5 degrees. So 37% of the population will have temperatures less than 97.5 degrees. Okay, so any questions about what we've talked about regarding using a StatCrunch, Excel, or the graphing calculator for normal distributions? If not, have a good day, have a good weekend, and I'll see you on Monday. We will continue to talk about the normal distribution.